Hi, in this video I will talk about 3D printing services available for ETAD researchers. You will learn how different 3D printing technology works and their strengths and weaknesses. On top of that, you will learn some common filament used for 3D printers as well as their pros and cons. I hope after this video you will find 3D printing no longer a mystery. Let's get started. The technology called FDM was invented by Scott Crump in 1980s, which is now commercially available. It fuses nozzle-melted filament made by coiled thermoplastic on a heated print bed to form desired parts layer by layer. Complex objects with overhangs or bridges will require support material to hold up these areas and prevent deformation. This technology is available at ETAD. SLA, invented by Chuck Hull, uses a photosensitive liquid resin that is hardened by using a light source. In contrast to FDM, an object is created through a build platform being lowered into the resin and a light source above or underneath hardening the material. The objects created are usually more accurate and smoother than FDM. However, this method is mainly used for small objects and has issues with larger objects. Unfortunately, this technology is not supported in ETAD yet. Now we'll be talking about some common material. ABS filament has significantly better mechanical properties, but at a relatively high price. It is strong and thermally stable. ABS can be easily sanded and is often machined, for example, drilled, after printing. However, ABS fusion must be operated under a stable, high-temperature environment, which makes it more complicated to work with. Another common 3D printing filament is PLA. It is biodegradable under the right treatment. It is also relatively cheaper for a 1 kilogram spool compared to the same grade of ABS. Its lower heat resistance makes it easier to handle with. However, it tends to creep under room temperature, which means that it will lose its original shape over time. Printing with resin is more expensive, both in terms of the printer and the raw materials. Where the resolution of FDM printing is limited by the size of the nozzle extruding the filament, resin-based printing is only limited by the size of the laser being emitted into the liquid resin. This allows resin printing to reproduce very fine details in its models. The curing process allows for stronger layer-to-layer adhesion in resin-based printing, resulting in finished projects with great mechanical properties that are much more uniform across all axes. Now let's talk about the 3D printers that ETAD offers. The FlashForge Creator Pro printer is ideal for ABS filament since it has an isolated working environment. PLA can also be used. Its dual extruder printing ability provides users with dual color printing as well as dual material printing. However, it has a relatively small build volume. Any parts that are larger than its build volume must not be printed. When printing with ABS, the door and the top cover must remain closed during the operation since ABS fusion requires thermal stability. This printer is connected to a PC, which serves the purpose for some advanced operation. The next 3D printer is the Prusa i3 Mark II printer, which is ideal for PLA filament. The print job resolution of this is one of the finest among its class. It can handle slow, medium, and fast print process extremely well. This printer is connected to a cloud service run by CalIT2. A great additional resource for ETAD students to 3D print would be at FabWorks. This 3D printing service is located on the second floor of CalIT2. Please note that fees are applied. Of course, Rome was not built in a day. 3D printing is a profession that needs constant practice and learning. Here are some resources that may help you learn more about it. They have great 3D Printer 101 videos as well as some tricks and hacks. Thank you for watching!